Well, welcome. For those of you who don't know me, and I think a number of you I've talked to you on the phone or been copied in on emails. But for those of you who don't know me, I'm Jay Chance. I'm with Republic Manufacturing. We used to be Jost Industrial, but in the last 10 years that I've been here in Utah, I've been fortunate enough to work with TES to be a supplier of vacuum pumps and blowers, and hopefully a source of information over that time. While I've been doing that, I've worked with TES, some of their customers, as well as some other encapsulation companies here in the area to deal with uh, an issue that seems to come up with just about anyone that's working with encapsulation, and that is inlet filtration. There was a time years ago that liquid ring pumps were the standard when it came to capsule separation because of their ability to take in powders, take in foreign particulate, and just spit it right back out the discharge with water. Unfortunately, or I guess fortunately, we're a lot more water conscious in the industrial space, and those once through liquid ring pump systems just are no longer the norm. We're moving more toward dry contactless vacuum pumps and chambers, and that comes with a flip side, which is we have to filter the inlet of the pump. So I'm hoping that this morning I can share with you guys some common mistakes, get you some information about kind of how these pumps work, why they work, and how we've implemented some filtration practices and programs in facilities and been able to help minimize downtime and required repairs or replacements on these pumps. So that's kind of what we're getting to. If there are any questions, don't hesitate to let me know. They're probably the same for other people on the meeting, and if not, we can certainly regroup afterward or address any concerns or questions that you may have more specifically via email or through the guys there at TES. So moving forward, so one of the two technologies that TES uses are the regenerative or ring blowers. From the outside, they kind of look just like a centrifugal fan. You got an impeller turning inside of a chamber, but what makes the regenerative blower or ring blower work is this ring chamber on either side of the impeller blades, actually allowing this blower to regenerate that pressure or vacuum and reach a much deeper vacuum or higher pressure than its centrifugal fan counterparts. Uh, what I wanted to show you on the internals of this pump are the tight tolerances. So you have tight tolerances between the body of the impellers and the ring itself, as well as the outside radius of the chamber. All of those are points where particulate, especially the powders that you guys are dealing with, are going to want to stick and build up and eventually cause impact and crash. Dry and contactless really must remain contactless for these pumps to continue to work. Here we've got the normal TES kind of setup. There are 3 different blower sizes, but all come with the same standard inlet filter canister set at a 90-degree angle. So you're not dropping powder down into the pump for filter changes. Most of the time, you guys are using a pre-filter, this fabric or sock filter that comes from TES, but this is kind of generally the setup you're looking at, which is just 2 of those stages we just looked at in that cutaway. So you have a first and second stage, but just 2 impellers doing the same thing that we just looked at. The other type of vacuum pump that TES offers on their machines is a dry claw. So very similar internal tolerances, very tight tolerances inside that claw. If you're familiar with a supercharger or a roots blower, the claw profile takes that dual lobe profile, adds the clawed tips, and gives these vacuum pumps the ability to reach about 24 inches of mercury at sea level. But again, dry and contactless, everything's tight inside that chamber, but the introduction of any kind of particulate, especially something that's sticky, is gonna tighten up those tolerances, increase the internal temperatures within the pump, and eventually cause failure. So that's pretty much how these pumps work. This is our 120 and 160 line that some of you may be familiar with. And I added a photo here of one of our pumps in testing, again with that canister at a 90-degree angle. So any powder that's not caught in the filter is going to fall to the walls of that canister. And here's our standard inlet filter canister, rated for 175 CFM. The paper element is rated for 5 micron. That CFM rating is important because we want to be above the CFM open flow of the pumps themselves. So you can see all of the regen blower performance flow here. So we're at 3 times the open flow of the 420, double the open flow of the 520, and you know, a good deal over the open flow of the 620, as well as on our claws of the 120 and 160. That's important because you're adding capacity to the filter. So when these things are running wide open, pulling vacuum, you should have some extra capacity. And then what we deal with after that is controlling the amount of powder or particulate making its way to this filter, and we're gonna continue to discuss that. We say 5 micron. I just wanted to make sure that people are kind of clear on how tight a filter 5 micron is. So what you're looking at here is a cutaway of a human hair. 50 to 70 micron is the width of a human hair. You can see some other little cutaways: pollen, ragweed, dust mite feces, which is like pretty unpleasant, I guess. And this little dot on the face of this cutaway of a human hair is a micron. So 5 of those, that's the filtration level of these filters when they're in good working order, no holes, no tears. There is nothing that should be within production that's going to be smaller than 5 micron. I mean, the finest dust, I guess, could maybe get through there, but that just gives you an idea as to what we're talking about when we're getting to 5 micron. The various parts and pieces on the canister, I think sometimes can get overlooked, and in talking with facilities that are having a lot of product pass through with their filters, this is the first thing that we look at. We take off the lid of the canister, get into the body of that canister, and the first thing I do is I pull out this, it's called a butterfly seal. If you look at this gasket or seal from the side, it kind of has a wing shape that they call a butterfly seal. But that seal itself is a big part of how this canister works. If that seal is damaged, you're gonna have an introduction of product through that filter, right into the machine. The filter elements themselves, whether they are this caged style with cork gaskets on the top and bottom, or the open style with rubber gaskets on the top and bottom, it's very important that, of course, those gaskets remain installed. I have seen situations where that gasket either falls off, it's been used too many times, and there's nothing there. Every one of these seals, from the seal at the bottom of the canister to the seals on the top and bottom of the filter elements themselves to the O-ring that goes around the lid of the canister, needs to be tight and installed properly, or you're going to have a path of least resistance for the particulate to make its way into the pump. The other thing to note here are the clamps. As these filter canisters are opened and closed time and time again, those clamps can wear, they can get loose, they're easily replaced. You're just kind of opening the ends of the clamps and closing them back on the little brackets that are provided on the canister. All of those parts are readily available. The various seals, O-rings, and clamps are easily replaced. One thing I will note, that when you are replacing the seal at the bottom of the canister, you want to make sure that you have a nice clean surface around the nipple at the bottom of the canister, so that you're not you the vacuum pumps, all of the pumps that we've talked about, will actually have the ability to suck past uh, that seal if you don't have a nice tight fit there. And you'd be able to feel that when you pull the seal out from the bottom of the canister. There should be some resistance there. It shouldn't just slide right out. And the same when you're putting it back on. There should be a nice tight uh, uh, fit as you're reinstalling that seal. So we're going to go through some of the things that I've seen over the years. We see them in a lot of different facilities. These are obviously never people trying to do the wrong thing, but they're things that we see often. The first, and I think that because your filter canisters come installed most of the time by TES and their technicians, this is not as big of a concern, but it's definitely worth mentioning, and that is a canister set straight up and down vertically into the inlet of the pump. In a situation like this, you're going to have excess dust, excess powder, and when people come in to replace the filter element, in this case, any built up powder inside the canister just goes right in, and you end up with a slog of powder. So anytime that you have a vacuum pump with a filter that is set straight up and down, you want to throw that thing on a 90 and save yourself a lot of headache. Uh, that's a big one that's easily remedied, and we see it a lot. Reusing old filters that are past their prime. Actually pulled this one out of a machine yesterday and thought it would make a good addition to our discussion today. At some point, the filters are beyond use. When they're absolutely caked in product and debris, sometimes you just gotta toss them out. Filters are inexpensive compared to repairs and replacement and downtime. And we're going to talk a little bit about in the filtration programs that we've done with other people. Talk a little bit about what you're doing when you're inspecting these filters, how to clean them. I just wanted to just put a plug in there. At some point, you just throw them away. Going back to the various components in the filter canisters and housings themselves, if you have a gasket that's worn or has taken on so much product that it becomes kind of brittle or hardened, you're not going to get the nice sealing effect that you want. So as part of your regular maintenance, as part of your filtration program, the various parts of your canister, this is actually that butterfly seal down in the bottom of a canister that is just completely covered in powder, and you can see actually blown right past the discharge of the filter, the inside of that pump is already covered in powder, so it's already ingesting particulate. In this case, the customer was just putting in brand new elements time and time again, but without a good seal on the bottom of the canister, you're going to get a lot of material passing through. Excess powder in the canister. Now we're going to talk about different things that can be done to mitigate the amount of powder making its way to the pumps, but this is why you have the filter setting at a 90 degree. Every time you put in a new element, you want to remove as much of this powder from the canister as possible. When this pump turns back on, if a filter is just thrown back into this canister, when this pump turns back on, the flow is going to kick up that dust and pull it right up into the filter, and you're going to get a lot less usable runtime out of the filter if you leave any of this particulate in the canister itself. So take your time, swipe out as much of that powder as possible. Even pulling out your gasket or your seal and reestablishing that seal between the canister and that butterfly seal makes a big difference. And then this is it's hard to illustrate, but this is a filter that, in an effort to get a filter back into the canister, we see a lot of operators and maintenance folks tapping or banging the filter on the ground or on a piece of equipment, and you can see this bright light that the arrow is pointing to on that pleated filter media where the filter meets the end cap. That is held on there with an epoxy, and when that filter gets banged or even tapped against the ground or a piece of equipment to remove as much powder as possible, that epoxy can break off. In this case, you had an eighth of an inch of just open air right into the pump. Any filter that's damaged, tears in the paper, missing epoxy, that's that's going to create a path of least resistance for the particulate and go directly into the pump, and that can only go on for so long. So as far as cleaning the filters, this is probably the best time to discuss that. You want to clean the filters with air, compressed air, through a gun or a nozzle. So you're not going to want to put 120 psi directly into that filter. So if you can regulate that down to somewhere in the 45 to 60 psi range and blow those filters out from the inside out, that's the best way to clean the filter and preserve the filter for future use. It's pretty straightforward. I know that the more and more time that you're spending doing this, it's not time that the pump is operational and doing what it needs to do, and that's pull vacuum on the encapsulator. But we're going to talk a little bit about kind of how we've had success in other facilities. But cleaning the filters out properly is going to extend the life of the filters themselves and ultimately the pumps as well. Going into past facilities and the success that we've had in implementing a filtration program, I kind of did just this quick write-up on what we've done. What we just talked about, cleaning the filter elements only with compressed air from the inside out, thorough inspection of the filter elements after cleaning. Generally, I try and pull that inspection away from production and into the maintenance team if there is one, or have one or two people within that team that are in charge of inspecting the filters, so that when there is a tear, when there is a filter that's gotten beyond its useful life, that those filters are being discarded and new or inspected elements are made available for production. Again, maintenance providing those pre-inspected elements so that there's no question on the part of production what elements are usable, what elements are good or bad. What we've found is that as facilities have a lot of usable elements within their kind of maintenance parts room, they're able to minimize the amount of product passing through the filters. Regular inspection of all the canister components and seals, adding that into either a weekly or I mean, as often as it makes sense to do. But if you add that into your normal maintenance of the pumps or the various parts or pieces of the encapsulator, you can catch a bad seal, you can catch a bad clamp, something that's not quite right. Having that as part of your regular maintenance definitely makes a big difference. And then with products and powders that have a higher amount of pass through, considering the addition of a particulate knockout or a pre-filter. I have a slide here in a second that's going to talk about some cyclone dust collection options that are available. But if you're seeing a lot of powder at the filter that's right at the pump, it's probably time to explore options for pre-filtration. That filter at the pump or the blower itself really should be your last protection for the equipment. Putting something in front of it to catch more of the powder is always going to be helpful, because obviously you're starting with 175 CFM of flow through the filter. That's going to go down with every minute that more and more powder is hitting that filter. So you're not only losing suction, but you're increasing the likelihood that you're going to have something get past that filter, because you're going to be opening and closing that canister pretty regularly throughout the shift. And then planning regular maintenance for the pump chamber. We're going to talk about the ability that you have to open the claw chambers themselves. You can open up and disassemble the regenerative blowers, but reassembly is far more difficult. But if it is possible, with your maintenance teams to get in and make cleaning the claws part of your regular maintenance. No filter is going to be perfect. Production and maintenance are going to have some powder go by, and sometimes just getting in there on a regular basis, cleaning out the claws and kind of having a fresh start before any kind of catastrophic failure takes place is good practice. Something that I've talked about with Rob and the team there at TES is the possible addition of a cyclone separator to try and catch more of the particulate if they can. There's a lot on the market. They're as simple as plastic cyclones on top of buckets, and they get as intricate as larger cyclones attached to 55-gallon drums, and they do a good job in knocking out that particulate. Anything that you can do to keep the powder from getting to that filter and causing multiple filter changes throughout a shift. The other option, and we see it in some facilities, is the addition of larger filter canisters. Inline, anything that's rated to 5 micron, you can put a T-style filter. These T-style filters with a bucket, even the polyethylene see-through bucket that can kind of give you a visual representation of where you're at as far as the powder coming through, can be helpful as well, and installed in line before a central system or each one of your individual pumps. The other thing that we've done, and I know it's in place in some of the facilities of TES's customers, are having a filter at the encapsulator and a filter at the vacuum pump. So that filter at the encapsulator is overseen by production with elements provided by maintenance. And then the filter at the vacuum pump is really just overseen by the maintenance team. And by kind of separating those duties as far as inspecting and taking care of the filtration, it can kind of give a second layer of protection for the pumps themselves by having both maintenance and production overseeing those. This is the inside of one of our RCV 120s, I believe. This pump has obviously ingested quite a bit of powder, but up until the point that we pulled this pump apart to the chamber here, this pump was running. Amp draw had increased a little bit, obviously, as the tolerances within the pump start to get tighter with a coating of powder. You're going to have higher temperatures, higher amp draw at the machine, but this pump did not fail. It was running up to the point that we cut power to it. Got the pump pulled down to this point, and with some warm water and a spray bottle and some scrapers and a little bit of elbow grease, you're able to return that pump to clean, brand new, ready to go, ready to be reassembled. You're talking about a matter of a couple dozen bolts to get to this point, and some time. Like I said, the best thing that we've found with the products that are generally coming out of these encapsulators is a little bit of warm water and scrapers. A thin shim can be used to clean out behind the claws themselves, but adding some time to get into these chambers and clean them on a regular basis. I have a facility that's doing every one of their pumps once a quarter. I have a facility that's doing every one of their pumps twice a year. But these were facilities that were sending pumps in for a rebuild sometimes once a month, and now we rarely see a rebuild type failure out of those facilities by adding in regular tear down and cleanup on their pumps. That's all I've got for my presentation, but I wanted to open the floor to any questions or concerns. Again, Jared and Rob, the entire team there at TES have my contact information. If there was anything that you wanted to address directly, I'm here to help. But does anyone have any questions over what we kind of went through here?
Yeah, so on the canisters, because we got them installed so they were going upright, and we assume that's how they went. And you're saying to put it at 90 degrees, so we can just change it doesn't matter which way we're pulling through that filter in this case, so we'll be pulling through the center as opposed to the outside of it.
You want to pull through the center using the center of the canister as the discharge. So the best way to do that is just to get a 90 pipe fitting. If you've got to raise it up with a nipple, you can raise it up so that it clears the body of the pump. But you definitely want to be pulling from the center of the filter into the pump. It just increases the surface area of the filter. The 5 micron filtration will work either way, but the surface area of that filter element is maximized if you're pulling through the center of the filter.
Okay, thank you.
Yep. Any other questions? Like I said, guys, the team at TES has my contact information. I'm happy to help. Look at any questions, address any concerns, and if it would be helpful to go more in depth on anything that we talked about today, we can certainly do that through Teams, through additional training. We're here to help. So if there's anything else that we need to do, please don't hesitate to reach out to the team there at TES, and we can coordinate additional training and help and whatever we need to do on the vacuum pumps. Thank you all for coming. I know time is money, so I appreciate your time, and we'll look forward to anything we can do in the future. Thanks everybody.
Appreciate it.
Thanks, Jay.